Alright guys, what's going on? I'm currently let's see what day it is actually. Day 34. Share my screen. I appreciate the 5 subscribers, man. Yesterday we were 125, 10, 130, so I guess we're growing good, man. So anybody that's new to this channel, what's up? I'm just trying to become better every day, so yeah, don't mind me just trying to get better. So today I'm just keep learning this right here, and then after this, I recently watched like an hour or 2 hour full video of Git in GitHub or whatever, and I understand it, but I'm not very. I thought I was good, but then I'm not very good. So I'll be doing this course as well. So yeah, we'll be doing a full course of Git. So setup, repositories, config, merge, rebase, all this stuff I will be learning. So the goal is to continue doing binary trees. I don't know how far I'm gonna get, and then start the Git, and then I would like to start. I don't know, man. Let's do some research, because obviously I know the STAR method for interviews, but I want to put it into practice. Like, after I finish this LeetCode thing in the Git, I can every day just start doing the STAR method and just getting better and better. So yeah, we can start doing this research after we finish our stuff. I really don't got much going on, so let's do it. What time is it? Alrighty. Okay. Sorry. Okay, cool. So we finished off on delete. So remember trees, whatever. But I guess we're focused on BSTs, so binary search trees, and binary search trees. Remember, binary search trees have list of children. Each node has at most 2 children. The left node value must be less than its parent's value. The rightmost must be greater than its parent's value. Yeah, so maybe we can have a picture. Yeah, so has to be less, has to be greater, has to be less, has to be greater, has to be less than this, has to be greater. So we know that the least would be all the way down here. So that was what this was doing, the min and max. So I guess the max is when we check all the way to the right side. Boom, boom, boom. That's the max. And then the left was the lowest. So the min and max is that. So current equals self. So while current dot left is not none, current equals current dot left. Current. So this is gonna go iterate down. So while this, and then while the child is none, then boom, return current dot go. So that's good. Now we're doing delete. I've been dodging this the last couple of days because I didn't want to fucking do this because it looks OD, man. So damn, my lighting is trash. If anybody recommends some type of good lighting, man, this light is like sucks. But then if I go like this, you know, the lighting looks good on the camera. So I don't know, man. I gotta get like another some type of lighting that helps out. So we're doing delete now. I remember in link list for delete, what we did was we set the last node to the next node, so and that skips it, or you could so-called say it deletes it. But binary search trees, I have no, like, before even looking at like what's going on, I just don't have a clue. Like, how would you delete? I'm not sure. Yeah, no clue. I try to think. I have no clue. We also need a way to remove users from binary search if a user decides to delete their account. Assignment. Implement the recursive delete method. It takes a value as an input and deletes the node with that value if it exists. Each call returns the new root of the tree or subtree after deletion. Notice that the test the delete method is called like this. You see dot delete characters. But I'll be honest, I'm not very good with being recursive. Oh shoot, this guy programming every day until I get a job. Nice. Sick. Let's see his videos. Getting sidetracked, but let's see his video real quick.
Yo, what's up, guys? Welcome back. We did episode 158 today. I was gonna quickly make that little recap video. I just got done looking at some C++ stuff, so it's kind of late. I kind of want to go to bed. So I think, yeah. So
cool. Yeah, he does these videos as well. Nice. Nice. Yeah, I'll go connect with this dude, man. This wasn't what I was trying to do, but let's see if I understanding. Actually, why don't we ask Boots right here? I am confused about recursive please educate me on it again. I know it's when you call, huh? It's okay, I don't care. I know that recursion is when you break down the code so it does smaller chunks one by one. Huh? I'm confused here, boy. Recursive programming is one like metric for now, but to start, how would you describe recursion in your own words? What I describe it as it's breaking down code in smaller steps in order to complete a bigger step. I don't know. Version does not involve breaking down. Now think about how this breaking down happens. What's the key action a recursive function performs to tackle those smaller steps? What do recursive functions do within its own definition? It calls itself. It calls itself. Indeed it does. Recursion calls itself to solve those smaller parts of the problem. Now imagine a wizard casting a spell that calls another wizard who then calls another, and so on. What would happen if it wasn't a way to stop the chain of calls? If programming was a crucial element that prevents a recursive function from calling itself endlessly. Return? But what kind of condition is... I don't know. I forgot. Wait. What kind of recursive function finally return a value without calling itself again? Do it like this. this. If you're telling a story and part of the story is to tell another story, then you eventually need a story that doesn't tell another story, right? Otherwise, you'll be the base case. So a recursive function needs two main things. Sorry. Honestly, I think I'm gonna watch this video. I think I'm gonna start doing this because I'm not very good with recursion, man. I fucking suck at it. So every time I talk about recursion, I just don't know what the fuck is, like, golly, I need to get better with this. So I guess I'm getting sidetracked and doing recursion now. Recursion is a famously tricky concept to grasp, but it's honestly quite simple. Don't let infinity of a recursive function is just a function that calls itself. It's a process of defining something in smaller.
Recursion is a word used to strike fear into the hearts of new programmers. It's a simple concept that just takes a second to learn how to use properly. Recursion is just when a function calls itself. Now, that might sound fairly straightforward, and it is, but it is one of the hardest concepts for new developers to learn. So don't beat yourself up if it takes just a little extra practice and a few more examples before you fully understand what's going on. Let's take a look at this simple example. We've got a function called countdown, and it takes as input n, an integer. First, it just prints n. After it prints n, it calls itself again, but only after subtracting 1 from n. So what happens if we call countdown and pass in 5 as n? Well, first, 5 is printed to the console.
So just go down 4, 3, 2, 1. So 5. So I have to do countdown 4 after?
Then countdown is called again, but this time with n minus 1, or 5 minus 1, which is 4. So we go back to the top of the function. Now we'll print n, which is 4. All countdown again, this time with 3. And on forever. So we've figured out the recursive part, but the problem is this function will never stop.
I can't stop.
It will keep calling countdown over and over and over, decrementing by 1 every time, even into
That's why he was talking about a base case.
the negatives. Countdown with -1, -2, -3. So what we need is a base case to stop the recursive madness. Let's add an if statement to the top of the countdown function. If n is less than or equal to 0, instead of printing n and recursing again with n minus 1, we'll just print the word blast off to the console and return immediately, again stopping the recursion. So what happens now if we call countdown with n of 5? First, 5 is printed, then we call countdown again, and that's because 5 is greater than 0, so we're not going to trigger that base case. Next, countdown is called with an n of 4. Again, we're skipping the base case because n is greater than 0, 4 is printed to the console. This continues all the way down until n is less than or equal to 0. So when n is 0, we'll enter that if statement, print blast off, and then return. And because we're returning, there will be no more recursive calls to the countdown function. So the final result is that when we call countdown of 5, 5, 4, 3, 2, 1 blast off is printed to the console. Now let's take a look at one more example. Let's say we want to write a function called dictDepth that returns the depth of an arbitrarily nested dictionary. For example, this dictionary only has a depth of 1. It has 2 key value pairs, but there's no nested dictionaries within it. But if you take a look at this dictionary, it has 3 nested levels. Melee weapons corresponds to a second dictionary, which has the key stabbies, which corresponds to to another nested dictionary, a total of 3 levels. Now, because the dictionary passed into our function can be arbitrarily deep, recursion is a really good fit for this problem. So let's figure out what our function signature should be. We'll define the new function, we'll call it dict_depth, and we'll pass in 2 parameters, d, the dictionary itself, and then max depth so far, which is just going to keep track of how far into the nested dictionary we are at each level of recursion. Now this time let's start with the base case, just so we have a different way of approaching this problem. And our base case should be when there's no more dictionaries to recurse into. So if d is not a valid dictionary, for example, if it's just a number, like the number that corresponds with the Bose key, 6, then we're going to stop recursing. So we'll just add this if statement that says, if D is not a valid dictionary, immediately return the max depth so far. Okay, now we need a recursive case. We need to figure out how to go from the top level dictionary to the next level nested dictionary, or dictionaries, because there can be multiple key value pairs. So first, we'll set a current max variable equal to the max depth so far. And the purpose of this variable will be to keep track of the max depth of all the nested.
I'm confused.
Because the dictionary passed into our function can be arbitrarily deep, recursion is a really good fit for this problem. So let's figure out what our function signature should be. We'll define the new function, we'll call it dict_depth, and we'll pass in 2 parameters, d, the dictionary itself, and then max depth so far, which is just going to keep track of how far into the nested dictionary we are at each level of recursion. Now this time let's start with the base case, just so we have a different way of approaching this problem. And our base case should be when there's no more dictionaries to recurse into. So if d is not a valid dictionary, for example,
So if not instance D is not in or
if it's just a number, like the number that corresponds with the Bose key, 6, then we're going to stop recursing. So we'll just add this if statement that says, if D is not a valid dictionary, immediately return the max depth so far. Okay, now we need a recursive case. We need to figure out how to go from the top level dictionary to the next level nested dictionary, or dictionaries, because there can be multiple key value pairs. So first, we'll set a current max variable equal to the max depth so far. And the purpose of this variable will be to keep track of the max depth of all the nested dictionaries at this level. Next, we need to iterate over each potential dictionary at this level. In Python, there's a .values method that we can call on a dictionary object to get every value in that level of the dictionary. Now, at each key value pair, we'll recursively call dict_depth, but this time we'll only pass in that nested dictionary. So instead of passing in D, we're going to pass in V. We also need to increment the max depth so far by 1 because we're going 1 level deeper. Now, once that recursive call returns, it will return with the maximum depth of that sub dictionary. So we should track that max depth, and at the end of the loop, if that max depth is the greatest of all the nested sub dictionaries, that will be the one we'll return. So with the first call to dict_depth, we're going to pass in a dictionary, D. It has 3 layers. The first level has melee weapons as a key, which corresponds to a single dictionary. It's the only key at the top level. The second level has 2 keys, stabbies, which corresponds to third dictionary, and bows, which just corresponds to the number 6. Going down into that deepest level, we've got a dictionary with 2 keys again, spears and knives. Spears mapping to 4 and knives mapping to 3. We also pass in a max depth so far of 0, just because this is the first call. So what happens? Well, first, in this initial call to dict_depth, the base case is going to be skipped because we've passed it a valid dictionary. Next, we'll set the current max to the max depth so far, which is 0. And that will be overridden within our loop if we find a recursive call that returns a greater number. Now we iterate over all the key value pairs in the dictionary, which in this case is just the melee weapons key. We enter the recursive call, where we pass in the dictionary that corresponds with the melee weapons key, that subdictionary. We also increment the max depth so far to 1.
It's like so much going on.
Iterate over all the key value pairs in the dictionary, which in this case is just the melee weapons key. We enter the recursive call, where we pass in the dictionary that corresponds with the melee weapons key, that subdictionary. We also increment the max depth so far to 1. Within that recursive call, again, D is a valid dictionary. We'll set the current max to 1, which is what the max depth so far was. Then we'll iterate over each key value pair again. This time there are 2, the Stabby's key and the Bow's key. Because the Stabby's key is first, we'll start there. We'll kick off another recursive call, this time passing in the dictionary associated with the Stabby's key. We'll also increment the max depth so far to 2. We'll iterate over each key value pair. Again, there are 2, spears, 4, and knives, 3. Starting with the spears key, we move into another recursive call. This time, the value 4 is not a valid dictionary, so we trigger the base case and immediately return 3, which was the max depth so far that we passed in after incrementing it. Now we are back up a level after returning 3. We move on to the next key in the dictionary, the knives key. Again, it kicks off a recursive call. The max depth so far, again, is 3 because we've incremented it from its parent function where it was 2. Again, D is not a valid dictionary, so we'll immediately return 3. Now, back up again in that parent function. We've iterated over both key value pairs, and we're going to return the maximum of the 2 return values, which because they were both 3 is just 3. So that will return up the call stack again. Now we're back into the second call. There's another key for us to process, the Bow's key. That will kick off a recursive call. This time, D, again, is not a valid dictionary. It's just the value 6. So we'll return 2, because 2, again, is incremented from this call's parent function where it was 1. Now we've iterated over each key in the dictionary, the Stabby's key and the Bow's key. The recursive call to the Stabby's key returned to 3, while the recursive call to the Bow's key returned to 2. So this call, which will return the maximum of the 2, will return a 3. Now we're back in the original function. We've iterated over all the keys, which in this case was just the melee weapons key and its associated dictionary, and we'll return 3, and the recursion is done.
Bro, that was kind of OD. I don't know what, like, that's kind of hard to, I don't know. Recursion's kind of a little crazy. Damn. Okay. Is that about recursion you thought? So if len nums is equal to 0, return 0, base case. It's kind of clicking though, I'm not gonna lie, it's kind of clicking. Return nums, so the first one plus nums sum everything forward. So print sum of nums 1. Don't break your brain on the example. Let's break it down step by step. Holy shit, yeah. Thank you for freaking reading my mind, bro. Holy shit. Solve a small problem. Our goal is to sum all the numbers in a list. Our goal is to sum all the numbers, but we're not allowed to loop. So we start solving the smallest possible problem, summing the first number in the list with the rest of the list. So yeah, recurse. So what actually happens when we call sum we're actually calling some nums with a smaller list. And the first call that nums input was 1, 2, 3, 4, 5, but the next call is just 2, 3, 4, 5. We just keep calling some of those with smaller lists. Oh, I see. I see. I see. So, okay. The base case. So what happens when we get ends? That causes an empty list, right? So we need to write a base case to stop the madness. Base case of a recursive function is the part of a function that does not call itself. My bad, bro. My hair's annoying. So doc to doc can automatically generate layouts. Generate various layouts for a page. There are a lot of possible layouts. We need a factorial. Okay. If x. Okay, if the len of x is equal to 0, we're gonna return 0. Now, what we're gonna do is we're gonna do this, return the first one times factorial r with 1 and above, but thing with this, we gotta make this the x, right? So we keep moving on forward, and then we're gonna print on the outside some numbers is over there. Print or factorial r, and then x. Yeah, this makes sense. This has to be a parenthesis then. X is not defined, right? X isn't defined, so I don't know. This is all I need to do. Will it do? Oh, wait, will it do this? So the type int has no len. Oh, it doesn't. So I don't even need to do the len here. Oh fuck. So this is not the example though. We gotta do times x minus 1. Wait, what the fuck did I put a 0 here? Shouldn't this be x? Oh, I'm sorry. Dang it. This work. Guess this is just my math. Small problem is if x is equal to 0, if it's if x, so we're doing 5 factorial, so 5 times 4 times 3 times 2 times 1. If it's 0, return 0, bro. What? That makes no sense. This one is stupid. How? How is that not working? If x is equal to this, so 5 times, so remember, so return x times 4. Must be 5 times 4. Okay, remember. Okay, it's pretty easy. Just I'm just brain farting. So x is just one number. It's just 5 factorial. 0 factorial. Wait, 0 factorial is 1, right? Yeah. So that's why I'm not being stupid. That passed. But now now this is done. Okay, now the base case is done. So now we gotta do, when it keeps calling the function back, do 5 times so we gotta do x minus 1. Okay. And then we gotta do x equals x minus 1 each time. That's my only problem. It's just, all I need to figure out is how I could do. So it's gonna be 5 times. Okay, let's think about it logically what I'm doing. So it's gonna be 5 times 4 is 20. And it's gonna do 3 times 2 is 6. So that's how that's passing. And then it stops. And then that just stops. So this is the problem right here. I know it is. I just gotta figure it out. So it's just 5 times. Five times something that keeps down. So it's like 5. Fuck. Oh, dang, I told you that. That's my problem. Doesn't make sense. Oh, range. Damn. 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 I'm actually a moron. Hold up, guys. Dude, like, what am I doing? Why am I brain farting, bro? I don't know why I'm fucking lost. All I'm trying to do is decrease down, bro. Sorry guys, hold up. This will just be fun. What do we do plus? I don't give a fuck no more, bro. I really don't. I don't. I really 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 don't. You have to call it again, no? You have to call it. You have to call it. You have to call it. Dumbass. Fucking dumbass. Like, bro. How could you just do this? And then fuck 12. No. Okay, no, this is wrong. This is not the one. Damn, bro, it was right there. I knew I was right. I was fucking tweaking it. This made sense to me. And this go down. You know what my problem was? It's not fucking doing it again. It's not doing it again. This, boom, it stays at 6. No, man. This goes to 20. Okay, this is just doing 5 times 4, which is 20, and then it stops. The reason why it's not doing it fucking again, so you have to call it again, bro. Holy shit, I didn't mean that. You have to call this again, and then...
Bomboclat!
Damn, bro. It's so embarrassing. I think I understand recursion now. It's not that hard. Oh my god, it's so stupid, bro. Like, holy shit, Marty, you're right there, right there, right there. Wasted like fucking 40 minutes. It's okay. It's over with. Go, just keep going. Oh, that's why. I'm like, bro, why is it saying it's equal to the length of the word? I is probably at 0. And then example, hello with the 5 characters, land word is 5. So when I equals 5, we stop. That's why there's a plus fucking 1. I was like, why is it going up? That doesn't make sense. But obviously it makes sense because if it's the length, if print the word I, word plus I, boom. If it's 0, no, if it's element 3, we just skipped 3 words, so she should say fence. Yeah, there you go, I get it. My bad, guys, I'm a little slow, bro, so you have to bear with me, man. My god, man. Stupid, bro. Okay, this is what I'm gonna do. I'm gonna do this problem, go up to here, stop right here. After this, I'll probably call the video and then do some stuff on my own because I have a lot to do. I obviously wanna go back and do this, bro, but fuck, man. Huh? I didn't even do this shit. And then I really wanna do something else. Fuck, bro, I'm running out of time. Okay, let's just do this and then whatever. So this person, you may not understand recursion just yet, but just follow the instruction, you'll begin to grasp the fundamentals. So if keys or values you're saying keys, and it takes two lists as input and returns a dictionary. It takes two, yeah. Dude, I don't like recursion, bro. Like, I get what it's doing, bro. It's saying the Avatar Last Airbender, then we're trying to set that to this. So what the fuck? So am I supposed to return recursively call Zig's map on all but the first elements for keys and value? So what am I doing here? So we're doing this to that and this. Yeah, this one makes no fucking sense. Holy shit, bro. I'm about to lose my mind. If either the keys or values is empty, return an empty dictionary, right? Return an empty dictionary that takes care. I'm curious if this works. Yeah, let's try this out. So keys is equal to nothing, and then hold up. Oh my god. And then values is equal to nothing, and if this is equal to nothing, we wanna, let's just say friends. Oh shit, nice. It does work. This shit recursively calls Zig map on all but the first elements. Oh my god, I guess. Zip map? Is that what I mean? On all but the first elements from keys and values. I don't fucking get this, bro. What do you mean? Like, I've been doing this here, bro. Fucking. Like, this is the recursion part. Recursive called zip map. Does not return like recursively. Just fucking. Bro, I don't fucking know. I don't fucking know. I'm losing my mind, bro. I'm losing my mind. I'm losing my mind. I'm fucking losing my mind. I'm losing my mind. I'm losing my mind. I'm losing my fucking mind. Bro, I don't fucking get this, bro. I fucking don't. I don't fucking get this. Bro, what? You asked for a dictionary. Oh. I guess this is it. Damn. Dude, this is weird. I don't like this fucking shit. Dude, just print 5. Dude, I didn't like the last one though, bro. I just didn't get it. Right, bro, I'm done with this, bro. I need a break and then I'm gonna hop back on. Later, guys. Thank you for tuning in. I'm not doing the best right now, so I need to get better. Fucking trash. Appreciate everybody for supporting. So means a lot to me. See you guys later.